So hello everyone, so in this lecture video we're going to be talking about in this case waste and recycling, and again this is actually one of the weeks in which we're going to be talking about waste. Specifically this week we're going to be talking about obviously this four learning objectives here, but just to give you a note, in this case learning objective 2 and 4, if you read it carefully, is actually the same. Okay, so that is actually that. So FYI, so in this case there is actually a legislation that actually in this case governs waste in the United States, and obviously that is the Resource Conservation and Recovery Act. Right, so there is actually a law that governs waste in the United States. So this is a waste definition. This is actually in your PowerPoint slides, again as usual. But waste, a lot of us think of waste as something that's used. That is actually not true. Even if you buy something new, let's say you went to Amazon and you bought, like, I don't know, a pair of pants that's like that you thought fits you. It comes to your house, it doesn't fit you, you throw it away. Well, that is waste, right? So the moment, just because something's new doesn't mean to say that it's not waste. All right. So again, once you have something and you decide that that something has no longer of any use to you, right? And you basically wants to get rid of it, even if it lives in your closet, that is technically waste at that point. Once you believe that there's no longer any use to you, that becomes waste. So that's basically what the technical definition of waste. All right. So it is not about like how new, how recent. Okay. So you don't use it, you have no need to use it, it's basically waste. All right. So that's that. There are many ways that you can actually classify waste. So this is just one of them. It's about the physical states of matter, and obviously a lot of you hopefully should know that there are generally three main phases of matter. There's actually four phases of matter, but for our purposes we're talking about solid, liquid, and gas. Now, solid waste is very straightforward, right? So you can actually see it, you know, like it actually has a shape to it, right? So obviously like clippings, grass clippings, all of that stuff is solid waste. Liquid waste, liquid basically means to say that you can see it, but what happens is it actually runs. So if you dump it, it doesn't have a definite shape. It just basically just spreads all over the place, right? So that's actually what liquid waste is. Now, what's missing in this physical states of waste, obviously, as you can see, is gaseous waste. And the reason why that is if you think about it, the moment you create a waste that is in gas form, there is no way that you can contain it, right? It basically just dissipates into the atmosphere, into the air. So there's no way that you can actually, in this case, keep it back. If you think of it, technically speaking, carbon dioxide is actually waste, right? But obviously we cannot capture it, so therefore that's why we don't consider gaseous waste as physical states of waste. There is actually, however, a caveat, like an exception to that. Obviously, is if you create a gaseous waste, but if it's captured in a container, guess what? Then it becomes what we call as EPA solid waste, right? So just because it's gaseous, as long as it's in a container, it's still considered a solid waste under the EPA. All right. So again, that's another way that you can classify waste. Another way that you can classify waste, which all of us should know, is biodegradable and non-biodegradable. And FYI, this is about time, right? So because hypothetically speaking, plastics bottles, they eventually decompose, but the only difference between this and this, obviously, is this takes way longer, like many lifetimes over. Okay, biodegradable, if you want to think about it this way, is things that actually smells like after a couple of like days or weeks, right? Things that can actually break apart after a couple of weeks. So that's what biodegradable basically means. All right, so this is based upon time. The other way that you can obviously classify waste is its effects on the environment and on living beings, and that's where we have hazardous and non-hazardous waste. Hypothetically speaking, hazardous waste, you can actually see this in this case, this properties here, chemical properties. So if they're exposed to air, okay, or if they basically exposed to open flame, they ignite, that's ignitability. Corrosivity, reactivity, and toxicity, battery acid, like in this case, like meets all of this criteria. Lye, right? Bleach, okay? So all of those in high amounts are actually considered to be hazardous waste. Interestingly speaking, the Environmental Protection Agency, obviously, and the RCRA, the Resource Conservation Recovery Act, they just because something is hazardous waste is also dependent upon the amount. So if you create a hazardous waste but in such a small amount, they actually consider it as non-hazardous. That's quite stupid, but hey, I don't make the laws. That's how they wrote it. All right. So, and they actually allow, even though you can see that it's a hazardous waste, there's actually a lot of industries that's actually in this case exempted from this hazardous waste rule. Mining industries, by the way, they are actually not, so a lot of the waste that they actually created is exempt under this classification of hazardous and non-hazardous waste. The other interesting thing about these two classifications about hazardous and non-hazardous waste is radioactive waste is actually not classified under hazardous waste, and it has its own special classification, obviously, which is quite interesting if you ask me. But again, hazardous waste is basically danger to you, okay, and to the environment, okay, and to other living systems, obviously, and then hazardous are not. So that's basically speaking. Another caveat that I would like to tell you about this classification is obviously hazardous and non-hazardous waste is about amounts, right? Because if you drink too much water, water is obviously non-hazardous waste, you can still kill yourself, but that's besides the point. So obviously amounts do matter in this case. All right. And then we have this thing, classification of waste according to origin and type. This is for you to peruse. Everything that we can actually throw out into our municipal dump, into our recycling container, into our trash container, that's actually municipal solid waste. Then there are other things as biomedical waste, so that's from hospitals, so like blood, right? So that's a biomedical waste. Body parts, amputated body parts. Industrial waste, so that's from industries, so coal industries, whatever they make, whatever they spew out, that's industrial waste. If you're a farmer, you know what agricultural waste is. Manure is an agricultural waste if you don't use it. Obviously runoff, right? So fishery waste, not so much. Okay, we're actually not in Wisconsin. We actually don't have a lot of that, unless you actually have in this case a farm, like a fish farm, probably in Lake Michigan, which I have no idea who that company might be. And then look at this. Then we have radioactive waste. Okay, and radioactive waste is not just from nuclear power plants, which we think about. Okay, but you also have to think about there are some, in this case, research activity that actually creates radioactive waste, right? So there's also obviously some medical uses for radioactive components. That's actually where, like not chemotherapy, but radiotherapy, okay, so comes from. So that's when they bombard you with like isotopes of heavy, like of origins, and obviously that is actually a form of a radioactive waste, okay? And then obviously e-waste, so anything that's powered, okay, anything that you can actually pull out from a powered equipment, that's actually an e-waste. And most of the e-waste we're actually talking about, like in this case, heavy metals, okay, as well as rare earth metals like lanthanum, okay, tantalum, okay, all of those things are considered e-waste. All right. So there's a lot of many ways you can classify. So you can actually classify one thing into all of those classifications. I'll give you an example. A banana peel is a biodegradable waste. It's also a solid waste. It's also a non-hazardous waste, and it's also a municipal solid waste, right? So if I give you any object in your quizzes, okay, so that is actually how you would classify. You can classify all of any type of waste by this multiple types of classification. Okay, so I hope that makes sense. Now, obviously, we never want to make waste. And obviously, the reason why we create waste, again, is because we need to transform materials from one form to another. So I need to make fuel, right? I need to fuel my car with gasoline. Gasoline needs to be extracted from the ground. So obviously, in any process, as we mentioned previously, no matter transformation process is ever 100% efficient. So if you change one object into a different form, into a different usage, there's always going to be waste. right? So as long as we're trying to transfer materials in our everyday lives, there's always going to be waste. We will never live in a society that we have zero waste. Okay, that is quite impossible, because that obviously, in this case, defies the law of matter transformations. All right, but this is actually how you would think about this, and we will, from now on, you will hear about the 3 R's: reduce, reuse, recycle. First of all, your first step always is to not use. So if you need to buy something, don't buy it. That's reduce, right? If you buy something and you see that there's no longer any use for it, like let's say underwear, right? So this is a funny story, because my dad would do this. Like, so underwear, right? Eventually it has holes, you cannot use it anymore. My dad would recycle it as like in this case, as basically a rag, the wipe around the house. That's quite not quite cool, but, and you don't want visitors to see that you're actually wiping down the furniture with, with an underwear, but hey, that's what my dad does, right? And then the last thing obviously is recycle. Recycle basically means to say is you take that material and you break it apart into its multiple parts, and basically then you basically reuse, the components. But this requires more processing, right? In the reuse, you just take its form and use it. That's reuse. In recycle, you have to break apart its components and use it in other types of equipment. So obviously, prevention or reduction is the most important way that you can reduce waste. If you need to, so don't buy it if you don't use it, and then of course reusing it, right? So obviously, and then obviously the last thing is throwing it away, and then hopefully recycling it. What you don't want is disposal, or what you don't want is for things that you buy to just lay on a landfill and not have any use whatsoever. So that is actually what the least thing that you want to do when you talk about things that you use in your everyday life, okay? Right now, there's actually 2 ways that we do waste disposal in the United States and around the world. In the United States, we actually do a lot of dumps and landfills, okay? And then obviously in the rest of the world, like if you're in a third world country, we like to throw everything. And in fact, in the United States, we still do this. We basically throw it in Lake Michigan, okay? So, or there's another one which is called liquefaction or gasification. That's basically when incineration is also a way that you actually do attenuation, right? So when you burn something, when you take your, in this case, your yard waste and you burn it, that's actually gasification. So that's a dilute and disperse technique as well, right? Concentrate and contain, you basically just collect it and you keep it in a big yard. And then in this case, you actually just try to distribute it around. That's what dilute and disperse means, okay? Now, obviously, there are a lot of useful waste options out there. So resource recovery. So one of the interesting things is, I don't know if you know this already, is obviously you can, a lot of people in third world countries would actually go to garbage dumps, landfills, and what they'll do is they'll actually go and take components from televisions and stuff like that, and then they'll actually sell it. They're actually employed by a local company. That's resource recovery. So all of these garbage skids that you see in third world countries, like rifling through, like in this case, dumps, that's what they're doing is resource recovery, right? Composting and vermicomposting, obviously that can only be applied to biodegradable materials and non-proteinaceous materials, right? So I don't know if you know this, you shouldn't be throwing meat, high protein stuff in your compost, right? So that actually should go in your trash, okay? The only difference between this is obviously is vermicomposting. Vermin means worm, okay? Then we have this thing called energy recovery. What does this mean? So what does that mean is, if you think about it, right? So there's always going to be, and all of these things, if you think about it, is actually a form of energy recovery, right? So what you actually do is you take, it's like a resource recovery, but instead of recycling and selling it to someone else for something else, what you can actually do then is you can actually burn something. So they already do this, so you can actually burn trash, and then the burning of the trash then creates energy. It's a fuel for you to actually create energy for the electrical grid. And then all of these things is just burning, okay? The last thing is biomethanation or anaerobic digestion. It's quite interesting. What you do is you use bacteria, in this case, to actually again treat biodegradable materials, and then that bacteria creates methane, which then can be used as in this case as fuel, because obviously methane is a natural gas, right? All of these things are just technically burning. So that's all this is, All right. So this is basically it for this week, and I will be talking more about the second set of learning objectives next week.